the percent composition things that I gave you yesterday, and then there's a quick lab about like percent composition of the stuffing in Oreos, which is pretty awesome. So if you did the problems, let's see, 1 point. Oh, I wrote oh, that's silly. Oh, 6. Uh, 16.00 on yours. This is 1.00. So that's 72.06 U, 12.00 U, and let's see, 60 and another 36.96 U. So you know about glucose? Glucose is the fuel for your body. This is 180. Let's see. Wait, 1 point. Is your equation, your periodic table, is it 1.01 for hydrogen? It really doesn't matter. Yeah, 1.01. That'll get just a little bit more. 1.01. So this is like 12.11. Oops. Get rid of that. 12.12. So plus 0.12. Yeah, like 180.18 U. So what percent is carbon? The percent that's carbon is just, the mass of carbon, 72, I just wrote 27, 72.06 divided by 180.18. The 72.06 has 4 significant figures. The 180.18 has 5 significant figures. So you can express this with 4 significant figures, and it's useful to do that. 180.18. So it's like 39.99%. So despite the fact that carbon is only 25% of the atoms in the compound, it makes up about 40% of the mass of the compound itself. And even though there's the same amount of hydrogens as carbons and oxygens combined, the hydrogen makes up a very, very, very small mass. Hydrogen is the most common element in the entire universe, but it has the least amount of mass of any other element. So you might know all sugars end with ose. So glucose is the sugar that your body runs off of. On the molecular level, glucose is the fuel for your body. Okay, let's see. Then there's this copper carbonate is copper. So again, you got copper. There's one of them. You got a carbon. There's one. Oxygen. There's 3. Copper has a mass of 63.55. Carbon is 12.01. And oxygen is 16.00. So what does that come out to be? 63.55 U. This is just 12.01 U. And 3 at 16 is 48. Yeah, add those all up. Let's see, 63.55, 12.01, 48, 123.56. And the percent that is copper, so even though there's one copper atom out of the 5 atoms that make the compound up, the percent that's copper is 63.55 divided by 123.56. 63.55 divided by that. 51.43%. The 63.55 has 4 significant figures, so it's appropriate to express the percent with 4 significant figures. Don't round it to the nearest 1 or something like that. And then copper 2 chloride, copper 2 chloride is made up of a copper 2, so that's like Cu2 plus, and chlorine or chloride is Cl1 minus. So the compound copper 2 chloride has got to be, CuCl2. So you got to get the formula correct if you're going to get the percent composition correct as well. So there's a copper and 2 chlorines. So you got 1 copper, 2 chlorines. Copper is 63.55. Chlorine is 35.45. $134.45. So then the percent that's copper is just the mass of copper, 63.55 U, divided by the total mass, 134.45 U. 47.27. So even though there are twice as many chlorine atoms as there is the copper atom alone makes up about almost half of the mass of the whole compound. So it's not hard. Once you get it figured out, it's pretty straightforward to do. Now, the other way to think about percent composition is if you happen to know the percent composition and the total mass, you can calculate what the mass of the individual thing in the compound happens to be. So, for instance, in reverse, let's say you happen to know that copper carbonate is 51.43% copper and the total mass is 123.56. The mass of the copper alone must be equal to the total mass times like whatever percent it is of copper. In other words, if I go 123.56 U times 51.43%, that'll come out to be 63.55 U. What I'm demonstrating here is you can go in reverse. If you know what percent of the whole one thing is made up, if you multiply the percent by the mass of the whole thing, that will then give you the mass of the individual thing that makes up the total. So that's the whole principle behind the last problem, number 7. You've got silver nitrate. So let's say you happen to have a crystal of silver nitrate. That's like, not to say it's cubic, but 63.5%, maybe like about this much. This is the silver part of it. It's 63.50% silver. What's the mass of the silver in the whole thing? So if the whole thing has a mass of 52.60 grams, and if it's 63.50% silver, then the mass of silver is 52.60 grams times whatever percent. And you always do it, with a decimal, 0.6350. 52.6 times 0.635, 33.40. So that means that if the entire crystal, this is the silver part, and this part up here is whatever remains, the nitrate, then of the 52.60 grams, if 63.5% of it is silver, then this mass of the silver part has to be 33.4 grams. So to give you like a visualization of those proportions, picked up the lab on the way in. There's on the lab tables, there's little baggies of Oreos. Everything's individually packed, so you can have your own bag. There's also individually packed like forks and knives, and there's a little weighing cup. And what's going on is you got Oreos, and Oreos are, there's like the 2 Oreo, like the, what do you call it? The 2 cookies, which taste like trash. And then in between is the magic that you're buying, the cream filling. And you can get the regular Oreos, which are like a crime against humanity, or you can get the double stuff, which is where it's at. Or you can get those other ones, you know, the ones with the super thick stuffing. You know what I mean? Yeah. And you can go on Amazon and you can buy just the stuffing. You know about that? And Amazon sells, on Amazon, you can buy bags of just the marshmallows for Lucky Charms. And that's amazing too. So you don't get the trashy cereal part, you just get the amazing marshmallows. You can get all the clovers and rainbows you could ever want. So the thing about an Oreo is some of the mass of the Oreo is the cream filling, and some of the mass of the Oreo is the cookie. The percent that's the filling is the mass of the filling divided by the mass of the whole cookie. And so this question is, are double stuffed Oreos actually double stuffed? If they're double stuffed, you ought to expect twice as much of the filling per mass of the cookie. So what's in the bag? There's a Oreo, like double stuffed Oreo. There's regular Oreos, and then there's like Target brand Oreos, which they're pretty close. Don't eat them immediately. What you need to know is what's the mass of the whole cookie. So you can take the cookie and use the weighing dish. Now, what's important about the weighing dish is a few things. Whenever you have a balance, it's like, let me get this. Let me just get a new page. Whenever you take the balance, the pan of the balance itself, you never, ever, ever put anything directly on the pan of the balance. There's a few reasons for that. If you put something on the pan of the balance, like chemicals and stuff, it could react with the pan. You could put the stuff on the pan and it gets stuck to the pan. Here, if you actually want to eat the cookie, you can eat the cookie, but you don't know what was on the pan beforehand. So don't be like, putting stuff on the pan. So you always use a weighing dish. And we use, like, you can use a bunch of different things, just a little piece of paper. There's cupcake like liners on the lab table. So the deal is, what's important is to know the mass of the cupcake liner. So if the paper has a mass of like 1.27 grams, and then the paper plus the cookie is like 27.42 grams, the mass of the cookie is not the 27.42, but you need to subtract the mass of the paper from it. So 27.42 grams minus 1.27 grams, that gets you the mass of the cookie. And then what you got to do is get the cookie part separated from the cream, and then weigh just the cookie part. Just the the brown trashy cookie should go in the trash. Just garbage. You can twist them to get them open, or you can scrape the stuff off. But the plan isn't to weigh the cream, because that's sometimes difficult to deal with. But if you subtract the mass of just the chocolate cookie pieces from the mass of the whole cookie, that'll get you the mass of just the cream filling. And you can calculate the percent of the cookie that happens to be the cream. And the plan is you want to know what percent of the cookie is the cream for each of the cookies. And if the double stuffed is truly double stuffed, the percent composition of the cream part should be double for the double stuffed Oreos. But you're going to find out if it's like that. And then you can find out if the Target brand Oreos are like an equally good deal. And there's a couple percent composition problems at the end as practice too. All right, so you don't need goggles because there's no glassware, no chemicals, no flames. You don't have to eat the cookie. In fact, I wouldn't, but I'd only eat the double stuffed if I was going to eat them. Just lick the cream out of the middle. Hold on to those for the percent composition things, yeah. There's only 3 tables. The cookie bags and then the little The templates use a lab. Let's see what you're using here. If you're remote, I have data for the percent composition lab that I will upload. I shall like just do the experiment. So let me show you. Let's see. Yep. All right, hold on a second. The ground. I'll be there in just 1 second. So in the materials section, in Unit 7, stoichiometry, the percent or Oreo percent composition lab is right here, and a little bit later on, I'll update it with some values that you can use to calculate the percent composition for the Oreo cookies. There's like a ground fault up here.
Oh, I hate this.